Section 4.6, homework number 10. So first in part A, we're going to use partial products method to calculate, to multiply these two. So this is the example we did in class, 58 times 764. And usually we use the commutative property and we write down the number with more digits first. And so we're going to switch them because we know they are equal to each other by the commutative property. So we do 764 times 58. And when we do partial products method, and we just do, first we start with 8. We do 8 times 4. And then we do 8 times 60. Again, this 6 means 6 tenths to get 480. And then we do 8 times 700. That gives 5600. And when we're done with 8, we're going to multiply the 5, but 5 means 50. So we first do 50 times 4, which is 5 times 4, that's 200. And then we do 50 times 60. Again, that 6 means 6 tenths. So 50 times 60 gives us 3,000. And finally, we do 50 times 700. Or you can say 5 times 700. That gives us 3,500. Now we're going to add all of these together to get the answer. So that's the partial products method. And next we got to work this out with the common method, which is the standard algorithm. So we do 4 times 8, the same steps as we do in the partial products method, but we don't really write down all of these numbers. But we just put a little 3. So this 3 here, we don't really write it down. We just put it on top of 6. And then we are going to multiply 6 times 8. That gives us 48, but it's 48 tenths. So this actually means 48 tenths because we already have a 3 tenths there. So we're going to add 3 tenths and 48 tenths. That gives us 51 tenths. And that 51 tenths, we know 50 tenths actually gives us 500. But we are going to that's why we put the little 5 line up with the hundreds place, 7. So we multiply 7 and 8 to get 5600s, and plus the 500s, that gives us a total of 6100s. Okay, and then after we're done with the 8, it's kind of like distributing 8 to 4 to 6 to 4 to 60 to 700. Now we're going to multiply 5, which is 50. So 50 times all of these. So we're going to do 50 times 4. That's 200. But again, we are not going to write down 200. First of all, we have to put place a 0 here because this means times 50, and that 0 has to be brought down, because times 0, anything times 0 is just adding a 0. And then we're going to do 4 times 5, 5 times 4, which is 20. And we write down this 0, and automatically this 0 is going to be in the tens place. So we're going to do 20 tenths here. So we put a little 2 above there. And then we do 5 times 6, which gives us 30. So we're going to write down 30 plus that little 2 gives us 32. So we're going to put the 2 down, but the 30, the 3, line up with 100. And finally, we do 7 times 5, which is 3500s plus the 300s, and that's 3800s. Okay, so now we add them to get the answer. Okay, so these are the two methods. In part B, we're supposed to draw a large rectangle to represent an array for this multiplication. And also we subdivide the rectangle in a natural way so that the parts of the rectangle correspond to the steps in partial products method. So and also in part C, we want you to draw an array to rectangle so that the parts correspond to the steps in the common method. So for each method, we're supposed to draw rectangles. And so here I'm going to show you on the next page here. So this is the one for the partial products method. And if you remember, we have these 6 steps right here. 8 times 4, 8 times 60, 8 times 700, which are shown here. 8 times 4, 8 times 60, 8 times 700. And then we have 5 times each of them, 5 times 4, 5 times or 50 times 4, 50 times 60, 50 times 700, which are shown in here. And how did I get all of these? So literally you're going to have to break down 58 as 50 rows and 8 rows. 768 as 700 columns, 60 columns, and 4 columns. So always divide according to the place values. Don't divide any other way. And now when you look at it's literally the rows times columns, rows times columns, and rows times columns. So that will give you all these sections. And that's for the partial products method. And next we're going to look at the common method. And notice in the common method, we don't really we only have 2 steps. So it's just this and that, and combine, add them. So notice that this comes from 764 times 8, and the bottom one comes from 764 times 50. So when we draw this, notice 764, we don't have to break them down. We just keep them together. But 58, we're going to break them down as 50 rows and 8 rows. So that's what I did here. I divide the row into 50 rows and 8 rows. But for the columns, I keep it as 764. So now this little top section here, it's exactly 50 rows times 764 columns. Or you can switch them by the commutative property. And the bottom part right there, it's exactly 8 rows times 764 columns. So each of the section corresponds to a step in the common method. Okay, finally, the last part, for part D, we want to solve this by writing equations that use expanded forms and the distributive properties. So we cannot do common method, partial method. So what we do is we break down both numbers, 58 as 50 plus 8, 764 as 700 plus 60 plus 4. And now we're going to use the distributive property. In the distributive property, so first we're just going to ignore this 8. Don't worry about the 8. So we're going to distribute 50. So you can see in the red 50 is distributed 3 times to each of the numbers in the second pair of parentheses. So we have 50, 700, 50, 60, 54. And after we get the answer, we are going to put 8 back, and we are going to distribute 8. So we're going to cover 50 and not to let 50 confuse us. So we're going to distribute the blue 8. So we're going to have 8, 700, 8, 60, 8, 4. And notice that each of these actually corresponds to the process we do in the common method or in the partial products method. And after we add them together, yes, we also get the same answer. They want you to relate your equations to the steps in the partial products method. I guess you could just say a sentence, the partial products here are the same as those in the partial products method. Each step you see here, each of these steps are exactly the same as what we did in the partial products method right here.